Okay, we want to solve these simultaneous equations. I'm going to label them up. I'm going to call this equation 1, this equation 2, and this equation 3. And I'm looking at one of these letters and picking one that I want to eliminate. I'm going to pick the z's to eliminate. You could pick the x's or the y's, it's entirely up to you. I'm going to pick the z's though. So I've got minus 3, 4 and 2. I want to find the lowest common multiple of those, which is 12. I can make this become 12z, I can make that become 12z, and make that become 12z. So that's what I'm going to do. So I'm going to times the first equation through by 4, I'm going to times the second equation through by 3, and I'm going to times the third equation through by 6. So equation 1 will become 12x plus 8y minus 12z equals minus 52. Equation 2 is going to become 6x minus 9y plus 12z equals 72. And equation 3 is going to become 24x minus 30y plus 12z equals 132. So I've got 3 new equations. I'm going to label them up and I'll call this one A, this one B, and this one C. And the key thing is these are the same, which will allow me to eliminate the z's now. If I did equation A plus equation B, so this one plus this one, then the minus 12z and the plus 12z, I know they're going to cancel out. So if I do equation A plus equation B, I'll get 18x, I'll get minus y, those have disappeared, and minus 52 plus 72 is 20. So I've got another new equation that's got just x and y in it now. I am now going to do equation B, take away equation C, because I'll have 12z minus 12z, and so that will disappear as well. So doing that, in fact, actually, if I did that, I'll do 6x take away 24x, which would be minus 18x, which is a little bit awkward, so maybe I should have done C take away B instead, but it's fine, doesn't really matter. Then I'll have minus 9y minus minus, that's going to be a plus 30y, so that'll give me a plus 21y. The z's have disappeared now, and I've got 72 minus 132, so that's going to be minus 50. That's not, it's going to be minus 60, isn't it? Okay, so I've now managed to reduce this down to a regular GCSE question, and I want to eliminate the x's. Thankfully, luckily here, I've actually got to the point where these coefficients match up already, so that's nice and easy. I don't need to change these equations. If these weren't the same, then I'd need to maybe multiply these by some constant to get it so they are the same, but I don't need to do that here. I can just add these two equations together. So 18x add minus 18x, 0, minus y plus 21y, so that's 20y, and then I've got 20 plus minus 60, so that's minus 40. So y is minus 2. Now I know that y is minus 2, I can substitute that back into either here or here to work out x. I'll substitute it in here because it's easier. Don't need to worry about the 21 then. So I'd get 18x minus 2, so that's going to be plus 2, equals 20. So 18x equals 18, x equals 1. So I've got x and y. I am now going to go back to any of these equations at the top to work out what z's going to be. I will pick, I think I'm going to pick equation 2 here. So equation 2 is going to become 2x, so 2 times 1 is 2, minus 3y, So minus 3 times minus 2 is plus 6, plus 4z equals 24. So 8 plus 4z equals 24. So 4z is 16 and z equals 4. And I can always double check my answers here by substituting them back into these other equations. So for example, this in equation 3 here, 4 times 1 is 4, minus 5 times minus 2 is 10, so 4 plus 10 is 14, 2 times 4 is 8, 14 plus 8 is 22, so there we go, it does look like it works.